National Electrical Code Article 300 Wiring Methods, specifically 300.4a, states that NM cable shall be installed as specified in 300.4. In addition, NM cable shall not be installed where subject to severe physical damage, such as might be caused by stomping sharp objects, falling objects, heavy traffic, or similar causes. The interpretation of this code section becomes critical when considering common wiring practices. The code does not explicitly prohibit the installation of NM cable in the space between joists and sheetrock strapping. However, it could be argued that this location exposes the cable to severe physical damage, as it is susceptible to being stepped on, bumped, or otherwise damaged during construction or use of the space. Despite the potential code violation, it is a common practice in some areas to install NM cable in this location. This may be due to several factors. Firstly, time savings and reduced labor costs compared to installing running boards or strapping. Secondly, a lack of understanding of the code requirements. Thirdly, lack of enforcement by inspectors. When installing NM cable between joists and sheetrock strapping, it is important to consider the following aspects. Safety is paramount, and the cable is vulnerable to damage, which could create an electrical hazard. Code compliance is another critical factor, as it may be considered a violation of the NEC and could result in failed inspections. Demonstrating professionalism is also important, so installing the cable properly demonstrates professionalism and attention to detail. It is recommended to follow the NEC requirements and install NM cable in a location where it is protected from physical damage. This may involve installing running boards or strapping to secure the cable. While it may require additional time and effort, it ensures the safety and code compliance of the electrical installation. Let's delve deeper into the implications of 300.4 and its practical application. The intent of 300.4 is to prevent physical damage to wiring, which could lead to electrical faults, fires, or shocks. Installing NM cable in an area where it is likely to be stepped on or hit by objects clearly contradicts this intent. Consider the scenario of a garage or basement where items are often stored. Boxes, tools, or other heavy objects could easily come into contact with the NM cable if it simply run across the bottom of the joists. This could crush, puncture, or otherwise damage the cable, compromising its insulation and creating a hazardous situation. The question then becomes, what constitutes severe physical damage? The NEC doesn't provide an exhaustive list, but the examples given, such as stomping and falling objects, offer some guidance. The key is to assess the likelihood and severity of potential damage in a given location. In areas with high traffic or where objects are frequently moved, the risk of damage is greater. Therefore, additional protection for the NM cable is warranted. Running boards, also known as guard strips, are a common way to protect NM cable. These are typically wooden or plastic strips installed along the joist to provide a barrier between the cable and potential sources of damage. The cable is secured to the running board, ensuring that it's elevated and protected from direct contact. Strapping, another method of protection, involves securing the cable to the joist or other structural members using straps or staples. This helps to keep the cable taut and prevents it from sagging or coming into contact with other objects. However, strapping alone may not be sufficient in areas where the risk of physical damage is high. In such cases, running boards should be used in conjunction with strapping to provide maximum protection. Another important consideration is the type of NM cable being used. There are different types of NM cable available, each with varying degrees of protection. For example, an NMB cable has a nylon jacket that provides some resistance to abrasion and moisture. However, even NMB cable is not designed to withstand severe physical damage. In areas where the risk of damage is particularly high, it may be necessary to use a more robust wiring method, such as conduit. Conduit is a rigid metal or plastic tubing that provides excellent protection for wiring. It's commonly used in commercial and industrial applications where wiring is exposed to harsh conditions. While conduit is more expensive and time-consuming to install than NM cable, it offers superior protection and is often required by code in certain situations. The decision of whether to use running boards, strapping, or conduit depends on several factors, including the location of the wiring, the type of NM cable being used, and the local code requirements. It's important to consult with a qualified electrician or electrical inspector to determine the best wiring method for a particular application. In addition to physical protection, it's also important to consider the proper support and securing of NM cable. The NEC specifies the maximum distance between supports for NM cable, as well as the types of fasteners that can be used. Improper support can lead to sagging, which can put stress on the cable and increase the risk of damage. It's also important to avoid over-tightening fasteners, as this can damage the cable's insulation. When installing NM cable, it's crucial to follow all applicable code requirements and manufacturer's instructions. This will help to ensure a safe and reliable electrical installation. Failing to comply with code requirements can result in failed inspections, costly repairs, and potentially dangerous electrical hazards. Consider a practical scenario. Imagine wiring a new outlet in a basement. The NM cable is run across the bottom of the floor joists, directly above the area where storage boxes will be kept. Without proper protection, these boxes could easily rub against or press on the cable, potentially damaging it over time. To mitigate this risk, running boards should be installed along the joist to create a protective barrier. The NM cable can then be secured to the running boards, ensuring that it's elevated and protected from the storage boxes. In addition to running boards, it's also important to properly support the cable using straps or staples. The strap should be spaced according to the NEC requirements and should be tightened just enough to hold the cable securely without damaging its insulation. By taking these precautions, you can ensure that the NM cable is protected from physical damage and that the electrical installation is safe and code compliant. Now let's address the issue of common practice versus code compliance. As mentioned earlier, it's not uncommon to see NM cable installed without proper protection in some areas. This may be due to a lack of awareness of the code requirements, a desire to save time and money, or simply a lack of enforcement by local inspectors. However, just because something is common practice doesn't mean it's acceptable or safe. The NEC is designed to protect people and property from electrical hazards, and it's the responsibility of every electrician to follow its requirements. Ignoring code requirements in the name of expediency or cost savings is not only unprofessional but also potentially dangerous. It's important to remember that electrical installations are not a place to cut corners. The consequences of a faulty installation can be severe, ranging from electrical shocks and fires to property damage and even loss of life. Therefore, it's always best to err on the side of caution and follow the NEC requirements to the letter. If you're unsure about a particular code requirement, consult with a qualified electrician or electrical inspector. They can provide guidance and ensure that your electrical installation is safe and code compliant. Furthermore, it's important to stay up to date on the latest NEC requirements. The code is revised every 3 years, and new requirements are often added or existing requirements are modified. By staying informed, you can ensure that your electrical installations are always in compliance with the latest standards. The NEC is not just a set of rules, it's a living document that evolves to reflect the latest knowledge and best practices in electrical safety. By understanding and following the NEC requirements, you can contribute to a safer electrical environment for yourself, your family, and your community. In summary, the installation of NM cable between joists and sheetrock strapping is a common practice that may violate NEC 300.48, which prohibits installing NM cable where it is subject to severe physical damage. While it may seem like a time-saving and cost-effective approach, it can compromise safety and code compliance. To ensure a safe and professional electrical installation, it is recommended to follow the NEC requirements and install NM cable in a location where it is protected from physical damage, such as by using running boards or strapping. Remember to consult with a qualified electrician or electrical inspector if you have any questions or concerns. By prioritizing safety and code compliance, you can help to prevent electrical hazards and protect people and property. Consider the legal implications of non-compliance. If an electrical fire or injury occurs due to a code violation, the electrician or contractor responsible for the installation could be held liable. This could result in significant financial penalties, legal fees, and damage to their reputation. In some cases, criminal charges may even be filed. Therefore, it's essential to take code compliance seriously and to ensure that all electrical installations meet the required standards. Moreover, insurance companies may deny coverage for damages caused by code violations. This means that the property owner could be left to bear the full financial burden of repairs and injuries. This is another compelling reason to ensure that all electrical work is performed by qualified professionals who are familiar with the NEC and local code requirements. The NEC also addresses the issue of abandoned cables. Abandoned cables are those that are no longer in use but remain in place. These cables can pose a fire hazard, as they can become energized and overheat. The NEC requires that abandoned cables be removed unless they are properly identified and labeled. This helps to prevent accidental contact with energized cables and reduces the risk of fire. When removing abandoned cables, it's important to disconnect them from their power source and to properly dispose of them. Never simply cut the cables and leave them in place. This can create a dangerous situation for future workers who may come into contact with them. In addition to abandoned cables, the NEC also addresses the issue of cable management. Proper cable management is essential for maintaining a safe and organized electrical system. Cables should be neatly bundled and secured to prevent them from sagging, tangling, or coming into contact with other objects. This not only improves the appearance of the installation, but also reduces the risk of damage and electrical hazards. Cable ties, straps, and other cable management products can be used to organize and secure cables. These products are available in a variety of sizes and materials to suit different applications. When selecting cable management products, it's important to choose those that are specifically designed for electrical use and that meet the applicable code requirements. Another important aspect of electrical safety is grounding. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The NEC requires that all electrical systems be properly grounded to ensure the safety of people and property. Grounding electrodes, such as ground rods or metal washer pipes, are used to connect the electrical system to the earth. The size and type of grounding electrode required depends on the size of the electrical system and the local soil conditions. It's important to consult with a qualified electrician or electrical inspector to determine the proper grounding requirements for a particular application. In addition to grounding, the NEC also requires the use of ground fault circuit interrupters, or GFCIs, in certain locations. GFCIs are designed to detect small amounts of current leakage to ground and to quickly trip a circuit breaker, preventing electrical shock. GFCIs are commonly required in bathrooms, kitchens, garages, and other areas where there is a risk of contact with water. When installing GFCIs, it's important to follow the manufacturer's instructions and to test them regularly to ensure that they are functioning properly. If a GFCI fails to trip when tested, it should be replaced immediately. Electrical safety is not just the responsibility of electricians, it's everyone's responsibility. By understanding the basics of electrical safety and following the NEC requirements, you can help to prevent electrical hazards and protect yourself, your family, and your community. If you're not comfortable performing electrical work yourself, it's always best to hire a qualified electrician. They have the knowledge, skills, and experience to perform electrical installations safely and correctly. Never attempt to perform electrical work without proper training and qualifications. This can be extremely dangerous and can result in serious injury or death. Remember, electricity is a powerful force that should be treated with respect. By taking the necessary precautions and following the NEC requirements, you can ensure that your electrical system is safe and reliable.